Hello, and thanks for watching this video. Today, we will talk about understanding statistics when reading papers. Statistics can be scary, right? Let me tell you, when I started my nursing degree, I had very little knowledge of data analysis, but now stats are a key part of my working life. I certainly do not know everything about stats. I'm not a statistician, but in this video, I will try to give you a few pointers that hopefully will be helpful when reading papers that deal with numbers. So first of all, what do we mean when we talk about statistics as a science? As with everything in science, stats start from a problem, formulates a question, considers the correct methods, the statistical tests to answer that question, including which data will be required, and then analyzes the data. Usually when reading a paper, we find information about the statistics or data analysis within the methods section before the results section. As always in our videos, I will come up with a research question that we will use. And this will be, what is the relationship between patient age and their length of stay while in hospital? Okay, so let's go. How do we understand the statistical techniques and tests that might be reported in a paper? How do we know if they're good enough? First of all, let's make a broad distinction that between analysis carried out to describe the data and those to measure relationships between variables. It is important to remember that when we talk about relationships or associations, we do not necessarily talk about cause and effect. Observational studies can infer cause and effect if they're well conducted, but causality is a huge topic that would merit a separate video, so I will not go there today. And another quick note on terminology. What do we mean by variable? We mean any characteristic that can be measured. This can be quantitative variable, for example, age, or qualitative, for example, ethnicity, favorite color, most recent holiday location. And they're called variables because they can vary. Not everyone in a sample will have the exact same age, and not everyone will have the same favorite color. Let's go back to statistics. Examples of analysis to describe the data are 85% of the patients were admitted to hospital via the emergency department, and 15% were elective patients who were admitted for planned operations and procedures. In this case, you're using statistics to report how many patients are admitted unplanned versus planned. So you're using stats to describe how your data are distributed. Another way to use descriptive statistics is to say the mean age of patients admitted to the hospital in 2015 was 79 years old. So I won't spend too long talking about descriptive statistics, but in any paper that reports analysis of relationships between variables, it is really important to see their descriptive statistics first. Use your critical thinking. Has the paper identified all the important variables that relate to the research question? And if so, have they described them before jumping on to analyzing how they relate to each other? In our specific question, one would certainly expect to see descriptive data on patient age and the length of stay of these patients. But what else? For example, we might want to see data around the patient's mode of admission to hospital, their cognitive status, the number of comorbidities, their diagnostic groups. Have a think and see if you can come up with some more. We then move on to measuring the relationships between variables. There are many tests, meaning there are many methods of analyzing the data that one could conduct to measure relationships. And I cannot tell you about all of them here, but let me tell you that there is a main division that you should probably be aware of. And also remember, each test will have its limitations. No test is perfect, but some are more adequate and can give more accurate answers to our questions than others. For example, in our research question on the relationship between patient age and length of stay, a paper might talk about correlation tests to answer the question. So what do we mean by that? Through a correlation test, we describe the relationship between two variables in terms of what happens to one variable when the other one changes too. So in our example, what happens to length of stay when age changes? We find out by the correlation coefficients. If it's 0 or close to 0, it means that length of stay is independent on patient age. If it is a positive coefficient, it would indicate that the two variables move along together. When you observe longer length of stay, you find older patients. If the correlation coefficient is negative, it indicates that the two variables are linked by an opposite sign. As age increases, the length of stay decreases, and as age decreases, the length of stay increases. While this is important information, this type of relationship does not consider any other variables. There is no adjustment for other important variables that might modify the relationship. We simply know that two variables tend to change together or not. If we want to measure associations between variables more precisely, regression comes in. Important note of caution, papers rarely refer to regression models as regression models. They usually specify the exact type of models they use. So regression is an umbrella term that we use in statistics, but in papers you will find specific regression models described. As with everything else in this video, I do not have the time here to go into detail in terms of the different regression models. But I will tell you an important feature of all regression models is that they enable us to estimate the relationship so that we can predict, in our case, the length of stay for a given age based on patients' observable characteristics. Another important feature of regression is that it allows you to adjust your estimates for a number of factors that might be important. For example, what else might have an association with length of stay? You might want to check that authors have added these variables to their model. And how do we interpret that relationship? A paper that reports regression usually will report something called a coefficient. It might be called B or beta coefficient. Let's say, for example, that a paper found that the B coefficient of a linear regression for age is 0.12. What does that mean? It means that for every unit increase in age, so for each additional year of life a patient has lived, their predicted average length of stay will increase by 0.12 days. So the coefficient tells you how much length of stay is expected to increase if the coefficient is positive, or decrease if the coefficient is negative, when the independent variable, age, increases by 1 unit. In our case, the coefficient is positive, so it indicates how much length of stay will increase when age increases by 1 unit. Sometimes, instead of a coefficient, you might find an odds ratio. Odds ratios are used to compare the relative odds of the occurrence of the outcome. In our case, we could think about another outcome, for example, admission to the ICU during the stay. So the relative odds of the occurrence of the outcome given the exposure to a variable, for example, let's say age older than 65. The odds ratio cannot be a negative number, so to interpret it, we need to remember that any values below 1 mean that when the independent variable increases, the likelihood of the outcome reduces. So if in our example we found an odds ratio of 0.57, we interpret that as if patients are over 65, the likelihood of being admitted to ICU during their stay decreases by 43% compared to patients who are younger than 65. I hope you spotted that 0.57 and 43% and 43 together form 100. So that's how we calculated that 43%. Are you super confused? Try to find a paper that reports coefficients and or odds ratios and try to apply what you learned from this example. I will now add a little more on interpreting coefficients and or odds ratios. We need to look at confidence intervals too. A confidence interval is used to estimate the precision of the odds ratio. For example, if our odds ratio was 0.57 and confidence interval was 0.42 to 0.65, the confidence interval describes the interval where the true odds ratio actually might be with a certain probability. Remember when we said that coefficients and odds ratios were estimates, it literally means that So as with any estimate we make in life, an estimate could be precise or not so precise. A large confidence interval indicates a low level of precision of the odds ratio, whereas a small confidence interval indicates a higher precision of the odds ratio. How large is large though? That again depends, but usually if the values of the confidence interval overlap 1, we cannot really be sure about the effect of that independent variable, in our case, age. A last tip is about statistical significance. You will often read in papers that an association is statistically significant when a magic statistic called p-value, or p, is below 0.05. You might not believe this, but statisticians and many other scientists keep debating this and can become very aggravated if you use statistical significance as the be-all and end-all when interpreting findings. So my recommendation here is just do not pay too much attention at how big or small the p-value is, but just know that if it is below 0.05, then an association is considered statistically significant. You might ask, what about clinically significant or important to patients? These are certainly important too, so as usual, use your head first and do not fall into the trap of talking about cause and effect when a paper reports a relationship between two variables. A question I would encourage you to consider when reading papers that report relationships between variables is whether they make sense to you, what might explain the relationship, and what else could the authors consider that might change that relationship. This again shows that you're using a head-first approach and not just taking a small p-value as evidence of certainty of a relationship. Thank you very much for watching this video.